All right, we got another problem. So this problem is going to be exploring vectors and trying to understand vectors. We're given the location of a post office in relation to my house and your house, and we're going to be doing some vector operations on some vectors that we're going to make. So here is my coordinate plane. This entire problem, everything is with respect to the post office, so I'll put the post office at the origin. So it says that my house is located at XY coordinates. Well, it says my house is located 40 meters east and 25 meters south. So I'm right here. So I express that as 40, comma, negative 25. And it says that your house is located 30 meters south and 35 meters west. So somewhere over here. So it's 35 meters west, so that's negative 35. And it's 30 meters south, so that's negative 30. So part A says who lives farther from the post office, me or you. So it helps to be imagining these things as vectors. And why it helps is because we usually draw vectors as arrows. So when you think about it like this, it's kind of like each of us has some radius from the post office. And we just need to figure out how long is this line? How long is this arrow? And that corresponds to taking a magnitude. So I can find the magnitude of each of these vectors, and that will tell me who lives farther. So the magnitude of m equals the square root of 40 squared plus 25 squared, and that's going to be 47.2 meters. Okay. And I can do a similar thing where I take the magnitude of y. Magnitude of y equals the square root of 35 squared plus 30 squared. That's going to be 46.1. 47.2 is, of course, greater than 46.1, so I live farther from the post office. My vector arrow, which points from the post office to where I live, was longer. Okay, so part B says, suppose I needed to drop off a letter at the post office and then walk to your house. How far would I have to walk? So here I am. I am at my house. I'm going to walk to the post office, and then I'm going to walk to your house. So really, the total distance, D, we'll call it dB for part B, equals these two added up. 46.1 plus 47.2. It's going to equal like 93.4. 93.3. Duh. 3.3. Okay. Let me rewrite it just so people on the printed out version can read it. All right. So now part C is a little tricky. Part C says I need to walk. Now I suppose I want to walk from my house. Oh, I need to walk from my house straight to your house. So with vectors, this can get pretty kind of straightforward, right? I hope. That's the hope anyway. So with our vector addition, well, we know that this is the vector I want right here, right? Because I basically need to know how far is my house from your house. So, and remember with vector addition, I can do this plus this equals this third one over here. And the kind of remember when we do that tip to tail business? So if I'm adding three vectors, 1, 2, and 3, their sum is this vector, right? So then I can do, if I call this little vector D, I can do M plus D equals y. Or I can solve for d, since I know m and y. D equals y minus m, which equals negative 75, comma, negative 5. Okay? So now if we want to know how far we're walking, I just need to take the magnitude of this. So the magnitude of d equals square root of 75 squared plus 5 squared. And that's going to equal